And again, if you take a look at the Python Fundamentals curriculum, we're starting out with Lab 4.5, and you can just type in that code example and make sure that it works. And then we'd like to extend it to also report on the evening and handle midnight. And let me give you the 2-second tour of importing. We can do 4 different kinds of imports, I think.
So the line 79, when you specify the year and the month and the date, like a special date, that information, that the year information will be stored into the label under the datetime dot date. Would that be right?
Yeah, and I didn't actually catch that, so it just is returning it. But I could say x is equal to, and x is now a datetime object. We haven't yet talked about objects very much. And x has a bunch of members that'll give me information about the date that I have, datetime object that I have. And really quickly to talk about imports, the most basic import statement is to import a module. And it's just import and the name of the module. If the module doesn't exist, then you'll get an error. And this creates a variable in the local namespace called datetime that points to a module, and you can actually see where that module is stored. If your Python installation is shipped with the source code, you could go read the source code for the module, assuming that it's written in Python. Much of the standard library for Python is written in Python. Some of it is written in C for particularly high-performance modules. You can import something specific from a module. So to access that now command, as of that last import statement, I have to say datetime, which is a package. It's a module that contains other modules. Datetime, which is a module inside of datetime. And that seems like a lot of confusing typing. So I could get that second module by saying from datetime, import datetime. And now datetime is a variable that's pointing to a module inside the datetime module. Not everything is importable. Now is actually a function, so it's not importable. Only modules are importable. But I could rename modules that I import with a different name by just adding as name at the end. And again, that creates a variable in the local namespace that's pointing to a module that I imported. Yes, and ideally, you don't know the path to the modules. So lots of languages let you import code by specifying the path. Python prefers that you manage the path. It automatically puts all the system modules in your path. And then you don't have to know the path. And you don't do path-based imports. You do name-based imports. So there wouldn't be any sense of saying like import dot dot some module name. It's purely name-based, and either Python knows how to find it automatically or it doesn't. And there's ways to manage that. So I did actually specify. Yeah, I said from datetime, which is this module, import datetime, which is actually a class. Right. And if I just say import datetime, I will get the module. If I want to import something from it, I have to say from the module import something else. And don't worry too much about the mechanics of imports, because we'll talk about them at great length here. So all the top level built-in modules are in the site packages directory for Python, which on Windows is in Python 2.7 lib, I believe. Okay. So and it automatically sets up to look in that spot first whenever you run an import statement.
Okay, I see. Okay.
So are people starting on that lab? So if hours before 12, we can type morning. If it's before 18, which would be 6 o'clock afternoon. If it's less than 21, we type evening, else night. That's fine. There is actually, and you could say if hour is less than 12, and Python does, some languages don't let you chain arithmetic operators, but Python will. So let's see, x is equal to 10. That works as we would expect. And nicely enough, so does that. So that would say if x is greater than 11, less than 12, it's between 11 and 12. 11 is less than x, x is less than 12. In mathematical, yeah, exactly. A lot of languages would make you say, like, if x is less than 12 and x is greater than, and you can do it that way as well, but Python does allow the shortcutting arithmetic notation. So has everybody got their date parsing script working? It's got a few ifs and else ifs. Let's talk about some more complicated data types, and I'll just show something in answer to Yuli's question really quickly. We actually have a lab later on that is using a built-in module that lets us build complicated command line interfaces, optparse. But for really simple usages of command line interfaces, the sys module provides access to lots of our environment. And sys.argv is the list of command line arguments. There's also argc, which is the count. And those are kind of arcane names, but long-standing Unix practice. Oh, is there not argc? Nice. I'm printing argv, and it prints a list which has all the command line arguments that I give it. If I add command line arguments, there they are in argv. And the first one is always the name of the script that's currently executing. That seems really dumb. And not the date portion? So now is and that's actually some of the confusion with the date time. You first look at it and it kind of seems confusing, but it has portions for working with just times, just dates, differences between dates, differences between times, and now my variable now is equal to datetime.now, whatever the return value of that is, which is a datetime object that has the year, the month, the day, the hour, the minute, the second, the microsecond. Or there's a few built-in formatting methods that are somewhat limited, ISO format, but is more readable. So we were having trouble running help before, and help functions on existing objects. So if I say help date, there is no date. There is no variable named date. Help is a function that takes a variable. I do have a variable called now, and now is a datetime object, so I could call help on my now. And as far as syntax, it's just a function call. It requires parentheses. It accepts one argument, which is the thing that it is going to introspect and tell you about. It's there. It's in the list. It's just down a little ways. So this, the first functions help talks about, I'll start with underscores, and these are emulation functions. We'll talk about that when we get to OOP. They're basically ways to make your object respond to a variety of built-in operators. After that, anything that doesn't start with underscores, built-in functions to the object you're introspecting, and in this case, there's only about 12 of them or so not too bad. ISO format, you can specify a separator. It returns a string in ISO 8601 format. Separators used to separate the year from the time, defaults to T. Yeah. Yes, argv is always filled with whatever the command line arguments were that were passed to the script when it executes. And note in an interactive interpreter, I told you wrong, there is no argc. In my interactive interpreter, there is no script. It's the name of the interpreter. If you're actually running a script, the first command will always be the name of the interpreter. And there is no argc, which strikes me as really dumb, and I'm kind of convinced that there used to be. But you can use the built-in function length, len, to tell you how long a list is. OK, so let's talk about some more complicated types. Container types. We've already talked a little bit about lists. The syntax for lists is to put square brackets around a comma-separated list of values. Lists are mutable. We talked about that as well. Lists are ordered. There is a concept of order, which means that if you evaluate a list twice in a row without doing anything to it, its items are in the same order that they used to be. It's important because not all collection types in Python have a concept of order. And lists can be heterogeneous. You don't have to store only one kind of item in a list at a time. So this is perfectly legitimate. It's a list. It's got 3 different types of variables in it. You can initialize lists a couple of different ways. This is the normal way in which I would create a list just using the brackets. You can initialize empty lists with empty brackets with nothing inside them. You can also use the built-in list function, which returns an empty list and can also be used to convert some other type to a list. So you notice I pass it a string, and it converts that to a list of single characters. List, the function, will accept any type that supports iteration, which strings do, and a bunch of other types do, and will convert them to a list, which will be important later on. And then the cool thing about lists is that they are iterable. We can talk about positions in a list. Python uses zero position syntax, and it uses brackets to index into lists. So x is equal to list ASDF, which gets converted into a list of characters. And I can index to an individual spot in list by appending opening and closing brackets and a position to my list variable. That makes sense to everybody? Everybody's done that in other programming languages. Some languages make the first spot be 1, but Python has the first spot be 0 in a true computer science fashion, and the last spot be the length minus 1. You can add things to lists and change their contents. That's what mutable means. So not only can we fetch something at a single position, we can also assign to it. It's mutable. And lists have some utility functions. So I'm running the help function on my object, which is of type list. So it'll show me the help layout for the list object. And again, I'm going to ignore the underscore methods at the beginning, which list has a ton of. And it usefully has append. I can add things to the end. It has pop. You can see a little down. You can emulate stacks and queues with lists pretty trivially. It has count, which is a search function, not the length of the list. Lengths of lists are determined by the built-in len, which works on a bunch of different types. And we can also take things out of lists with the built-in del we talked about a little earlier.
How do you use that, for example, the count, of the list?
So that count function I just mentioned specifically because it doesn't return you the length of the list. What it actually does is search for values in a list and tell you how many there are. So there's one D, and there's no. And the built-in list type has a bunch of wonderful properties. The implementation is fascinating, but it has really fast indexing and sorting properties. So it's really common to use lists as the main tool by which you process things and in-place sort them or search on them. And those operations are extremely fast. List is the most heavily optimized data structure in Python, thanks to Tim Peters. So count says I'm passing a value D, and I'll look in my list and see how many times that value occurs. So my list X, it's searching. Yep. And similarly, there was index. Which will look at the values in my list and return me the position of the value if it's found. And if it's not, I'll get an error. Lists are iterable. It's our the first iterable type we're going to talk about. So we've looked at branching, ifs, and else. The other common thing you're going to do in scripts to manage your program flow is loop. And Python supports a couple kinds of loops. It supports for loops. And the syntax for for loops and their semantics are different than you might be familiar with. Other languages, for loops are specifically for indexing, specifically for looping over indexes into objects, typically. So if you're coming from a C or Java-ish language, you might be used to a for loop that looks something like this. If I could type, right? Something like that. There's a whole mini syntax in for loops. So for loops are really simple in Python. It is for value in iterable, and I'll say X in this case. And value is not the index. Value is the actual value. So when I run this for loop, it's printing the actual contents of my list. If you really want the index when you're looping over iterables, you can use the enumerate function. Which returns things two at a time. It returns a pair of the key and the value. But knowing the index of the thing in the list turns out to be a little less important in Python than in lots of other languages because of the richness of the built-in. Mm-hmm. Yep.
The difference between count and in the indexing, what's the count?
So count is how many times does the value I'm looking for occur in my list. So here's that. Makes sense? There's 2 zeros. And index will return the first occurrence if there is one. Otherwise, it'll throw an error. Yeah, so let's go back over the for loops real quickly. The first one that I did is this one. And the syntax is straightforward, right? It's a multi-line statement, so there's a colon at the end. The body of the statement is indented, which in this case is just one line, and it's printing the value. We're looping over an iterable, and when we loop over an iterable by default, we just get each value one at a time. But we don't know what position that value is, and we could look it up with the index function. But if for some reason you wanted to know what the index of everything was as you loop through, there is a built-in function frequently used called enumerate that takes an iterable, and instead of just giving you a value, gives you the position and the value, the index and the value. And when I ran this loop then, when I ran this loop then, instead of just printing the values like it did the first time, it prints first the index, which is k, and I could say I instead of k, I suppose. It's not really a key, it's an index, and the value. So we'll talk about all the built-in functions at some point. There's about 60 built-ins, and you really only need to know about 25 or 30 of them. And we will tour Python standard library that has a bunch of additional stuff. The built-ins are things you don't have to import to use. They're just there. And if you look at there's a special module called built-in. You don't need to explicitly import anything that's built in, hence the name built-in. But if you wanted to see everything that's built in, you could look at the attributes of the built-in module. Okay, there's 150 built-in things. That also includes all the values that are built in. But as far as built-in functions, there's 30 important ones. Yeah, I could use help on it as well. Which is really long because it's describing everything. It's describing every object in there as well as listing every object. Dir just lists the objects. Okay, and you could look, it's page 13 in your curriculum if you want to follow along. At the simple looping that we're talking about, there's, in addition to for loop, there's a while loop built into Python. People familiar with other programming languages, what's the difference between a for loop and a while loop? Yeah, so while loop, you're checking a condition, and you may not know how many times you want to execute. For loops are typically used when you know exactly how many times you want to run, or you're enumerating over something that has a predefined length. So while loops could potentially run without ever stopping, which is sometimes useful. And whiles are just like if statements. They take some sort of Boolean value, not necessarily an iterable. So we were looping over x with for. If I do while x, as long as x had something in it, my while loop would run forever because it's just evaluating the Booleanness of x. It's not actually iterating it. I could say while length x and pop removes the topmost first item in my list. So that works. While length x, the first time it runs the length function on my list x, which presumably had some stuff in it. Therefore, length is greater than 0. Therefore, my while condition is true. It runs the body of the loop. I pop something. I print x, 0, 0, and 5. And the little 9 in there is the return value of x.pop. And my interactive console is automatically showing me the value of every statement that I run. I wouldn't get that output if I ran this as a script. It runs again, length of x, and length of x is shorter, but there's still something in it, a couple of 3 values. I pop something off. It prints the thing that I popped off. There are 5, and prints x, which now has just 0 and 0, and so forth until my container is empty, in which case length of x returns 0, which is a truthy value of 0 or of false, and my while loop stops running. So while loops, like if statements, it's a multi-line statement. It ends in a colon. There's an indented body underneath. There's no parentheses around the Boolean condition necessary. Those are optional. And that's all for while. Yeah, and actually it's popping from the end of the list, so it by default is acting like a queue. But there's built-ins on the there's built-in functions to treat lists as though they were stacks or as though they were queues. First in, first out, or last in, first out, either way. So you can emulate stack or queue behavior with a list pretty trivially. The other cool thing about lists is they have a whole mini syntax built around those brackets. The next thing we're going to do is a lab where you're going to iterate over a list and explore the mini syntax around brackets. And this is somewhat unique to Python as far as I know. Lots of other languages you're familiar with have bracket-based indexing of things. Let's go ahead and give ourselves a list using a built-in function. Range is a built-in function, and it returns a list from the start value to just before the end value. So I have the values 0 through 9 in my list. And so far, we've looked at indexing to a particular position, and that works. Our brackets can take 3 values separated by colons to index, and they can take positive and negative numbers. And figuring out what all that means can be a little challenging. Let's start with the easy ones. The first number you pass a bracket is the starting position. And if you supply an ending position instead of returning a single piece of the index, a single value, it returns a slice. And it's nice that I've got the numbers synchronized up here. It's returning me the slice that is starting at the 5th position, 0, 1, 2, 3, 4, 5, through ending in the 7th position. And you can think about the positions as the commas in the list. They're sort of between the values. So I said 5 through 7, and that only gets me 5 and 6. It does not include the 7. The 7th position is right here. Yeah, if you think about it as the position of the item itself, then the slicing index is returning one before. The last one is not included. It's a non-inclusive. No, the last number is the position. No length of the slice. If I say 0 through 1, I get that single item. I get that single item. But if I say 1 through 2, I'm not getting a slice that's too long. I'm getting a slice that's made up by taking all the values between the first position and the second position. I can specify up to 3 numbers, but we're not there yet. Okay, so there's one more number I can specify. I can leave off anything I want to. So if I say just x1, that's the 1th position. If I say x colon and don't fill in the second number, it is assumed I mean to the end of the list. So that's how to get all the list except for the first item. I have a slice that starts at the 1st position, so right at that comma. And I left off the ending condition, but it would be the length of the list, so it would be the last comma here that's not actually printing out. And similarly, if I leave off the first number, it assumes you're starting at the beginning of the list. So I'm getting from the 0th position, which again isn't printed, through the 1, 2, 3, 3rd position, 0, 1, 2, 0, 1, and 2 here, 3 positions. Get the actual list I'm working on. And my numbers can be positive or negative. So anybody want to speculate about what that will do? I know I have a smiley face in brackets. Doesn't it seem wrong that this evaluates? So I left off the first number, and it would be by default the beginning of the list. So let's go ahead and put that in. So it's going to start at 0. The second number represents the position it's going to go to. And if you specify negative numbers, it starts at the end and counts backwards. So this is all the list except for the last item. And it's the exact same thing as saying the second position in my slice is the length of the list minus 1. Well, I can just leave off that length of the list and supply the minus 1. So again, if you think about other languages you've used where you have lists, and very frequently you do want things like give me everything except for the last one, or give me everything except for the first one, there's a built-in mini language between brackets. And the first condition can be negative. How about that one? What does that do? The first position is going to start at the end and count backwards. So let me get my actual list here. So it's starting here, 1, 2, 3, 4. Then the second number is left off, and by default that would be the end of the list. So this will get me the last 4 items in my list. And I could give them both negative numbers if my order works out, and say start from 4 back and go to 2 from the end. Crazy, right? Okay, there's one. Negative numbers are counting from the end of the list. Positive numbers are counting from the beginning of the list. Yep. One more semicolon. And it's always implied. And it's always 1 by default. But I can supply it and say 2. And in fact, let's do this. So it is. Very good. I have a start position of default because I didn't supply it. That would be the number before the first colon. Let's go ahead and supply it. I have an ending position of default. That would be the end of the list by default. I didn't supply it, but I could. And then 2 is how I'll increment. And this is getting me every other item in my list. Usually if I iterate over a list, I get every item. I can get every other item, or every third item, or every fourth item. And fortunately, negative numbers make no sense in this context, because I don't think I could take one more thing between square brackets. So 3 numbers. What's the first number represent? Starting point, starting location. And if all I specify is the first number, I just get a value, not a slice. I have to specify a second value, at least by putting in a colon, even if I don't say what the number is. But the second number is the ending location, defaults to the end of the list. And the third number is how I increment. Every one by default, but every other, etc. It's a whole mini syntax between brackets, and it's super incredibly useful, as you know if you've done list processing at all. Lots of stuff that is several function calls in other languages can be reduced to one bracket expression that you have to think about for just a second. So go ahead and make yourself a new file. Call it class.py. I would like you to put in that file a list that has all the names of your classmates. Print off the list with a for loop. So when you run it, it should print all the names one at a time in a for loop. And that much of the lab is in your textbook. It's lab 5.2. And it wants you to print hello name, where name is the first name. And then I'd like you to do 3 extra things. So go ahead and follow the instructions, all the first names. You can look at people's name tags. Print off each name, hello, name, in a for loop. And then print the last name in your list, not the last name, but the last item in your list. Print the last 2 items in your list, and print every other item in your list. Also using for loops and using our string slicing notation. Oh, and there's one thing I forgot to mention here, which is, it's kind of implied, but even if we're just specifying one position, i.e. we don't want to slice, we can still use negative numbers. So there you go for free. The last item in your list is -1. So it varies. I'll show you a PEP that is the preferred style for everything. A lot of the standard library comes from ports from other languages, so like the unit testing library is a ported JUnit, and so the unit test library uses Java's standards, which is all camel case. In general, Python prefers underscore and lowercase, particularly for variables, but it's really common to use camel case for classes and objects. And all uppercase for things intended to be constants, although Python does not have a constant type. Yep, the last name in your list, the last two names in your list, and every other name in your list. All in one program. So when you run it, it should print out hello, each of the names in the class, and then hello the last name, hello the last two names, hello every other name. This would be a good time actually while people are hitting labs. I pulled up a blog post earlier that I had put up from a previous class of additional resources you should know, and these might be useful as you're going through and doing labs. I personally am a big fan of Python in a nutshell, which is a desktop reference to the Python language and a good chunk of the standard library. It's Alex Martelli, one of the Python gurus. There are other books that are online that are more tutorial based, and I mentioned a couple of them, including the official Python tutorial and Dive into Python. Code Like a Pythonista you should read when you've completed this course, and we'll probably talk about it the last day a little bit. And also Doug Hellman's Python Module of the Week is now out in book form, and it's like 1,500 pages. It's like this gigantic book. But just to get a guided hands-on tour of Python standard lib, those are great. But in general, Python has really good documentation, and so you shouldn't restrict yourself to just the help function. You can go and look at Python's built-in documentation, and for instance, here's a list of all the built-in functions. And if you click on one, it's actually the same content as help, but frequently there will be some more tutorial-like usage with it. I do mention the built-ins and the keyword modules, which will give you a list of all the built-ins and keywords, and some tools which those of you who are on Windows should think about using a replacement console, possibly. I got a good question from Yuli, who's playing more with the first example, but to change the type of objects, a lot of languages use a keyword to cast the type from one to another, and Python actually uses functions, the built-in functions, and they're named after the type. So there's a function int that takes a value and attempts to make an integer out of it. Function float. There's a function str for strings, bool, B-O-O-L, for booleans, and they're all built-ins. That list of built-ins that I pulled up moments ago okay, so everybody's completed that. Alphabetize your list. And don't alphabetize it by going in and retyping anything. So I said that the built-in functions, or the built-in list type, has a concept of order. It also has a built-in sort function, and there's ways to pass your own comparator to the built-in sort function, but by default, it will try and sort the list if the list is homogeneous, or if all the types on the list provide their own comparison functions. It can successfully sort, and it's not very interesting to sort a list that was already sorted. There's also a reverse function, which sorts it and then reverses the order. And it works on strings, just goes by alphabetic case by default. And note that this is a destructive sort. It's modifying your list in place. So you have a different list after you call the sort function than you do before it. And a couple of other notes about lists we probably should mention. Lists are mutable types, and we talked about this really early on. But if I say y is equal to x, I have two tags on the same variable. That variable is mutable. So if I change one, I change the other. What if I wanted a copy of the first list to be able to modify, change, maybe sort, and not mess with the first one? There's some built-in functions for copying things in Python, but actually the default way of copying things is this. You'll see this idiom very frequently. I'm taking a slice of my list, and it's a slice that starts from the beginning and goes to the end. And slices return copies, so that if you take a slice and modify the slice, you don't modify the original. So in this case, now y and x look like the same thing. But in fact are not. So I made a copy with just brackets, colon, and that's implying the beginning of the list to the end of the list. Return me a slice that's as long as the whole list. It's a copy. Make sense? Yeah, so, and that's one other piece of syntax that we've been using and not explaining, but dot is the dereference operator for Python. And in Python, everything is an object. So in a lot of languages, you have a distinction between simple types and complex types that might have additional things besides their value. But everything, even simple types in Python, actually are objects, and they have a multiplicity of built-in functions on them. So yes, if x is a list of names, x has a member function just because it is a list called sort.
All these sort functions or reverse functions come as part of the list.
They are part of the list.
Right?
And notice there's not actually that much stuff to know here. I can't just highlight the last column. For lists, you need to know append. It adds it to the end. Count counts how many instances of a value. Extend lets you append one list to another. So append just gives you one more list. And let's look at that really quickly. With me so far, right? I just added one more value to my list. If I wanted to add another list that I had, this doesn't do what I want it to do. It means that the last position is a value that has two things, is a list itself. What I wanted to do I would have to use extend and it copies all the items from the iterable you give it and adds them to the list. I just did the range to get me back my original list without the stuff in it. So all range does is give me a list of numbers. Index we've talked about. Insert. Here's my list. It's position first, I think. Yeah.
Do I need to import anything to dereference the list?
Nope. List is built in.
X dot didn't give me an error.
X inserted at a particular place. There's pop, remove, reverse, and sort, which we've talked about. We've covered everything built in on lists. And let me look at your problem. And then there's one other piece of syntax to know about lists.
Okay, so X is a list when I dereference it.
Okay, so if you don't specify anything and just enter,
Mm-hmm.
it is a syntax error because you have to specify the name that you want to dereference it by. When I'm getting extra stuff, I'm hitting X and then tab in your interactive will autocomplete, and this gives you a list of all the things that you could say here. Like insert is one of those things.
What did you make it happen there?
So up here, I hit tab, and in my console, instead of showing a little pop-up like that, it prints out the whole list. But that's just this is not specific to Python. It's specific to IPython, which is an interactive console.
Okay.
And this is basically doing the same thing. I hit tab, and here you get a list instead of printing it out. This assumes you're running under a console-only terminal, and so it just prints out everything. What if you wanted to check and see if something was in a list? How could you do that? If I wanted to make sure that Yim's name was in my list of classmates, how could I do that? I could do count and check and see if the value of count was greater than 0. So I could do names.count Yim greater than 0. That would work in an if statement. The preferred way to do this, let's see if I still have a while laying around, is to use the in operator. And the in operator returns true or false, and it's just presence. And instead of doing if y.count Simeon is greater than 0 as my if statement, which does work, but you read that and it's not necessarily fluent. If I just say if Simeon in y, that's a lot more fluent, and the in operator supports a variety of types, as we'll see. Like strings. So I'm checking for the presence of a given character in a string. Okay, do we have enough time to tackle strings in a little more detail? We do. We got 10 minutes till lunchtime. Thoughts, questions?
So I'm trying to insert your name.
Okay, so insert takes a position and a value.
I see. So I would need to have.
So you need to have the position, and you can put 0 if you want to insert it at the top, which is the implementation of push if you're looking for stacks. But I should say, while the Python lists, they're really ridiculously performant, it's worthwhile if you're a C programmer to read Tim Peters' implementation of the sorting features in lists, because it's actually really cool. Several algorithms implemented depending on like how big the list is and whether it's heterogeneous or not. About the only performance gotcha is actually inserting at the beginning of lists. If you have very large lists, inserting at the beginning of lists is an expensive operation. Okay, so strings. Can we talk about strings a little bit more? We actually haven't done too much with strings. We've specified that we can use single quotes, double quotes, or triple quotes on strings. I forgot to mention the best part about, or the reason for triple quotes. And I should mention a couple other pieces of Python syntax. So the reason for triple quotes, among other things, is a triple quoted string can span multiple lines. By default, strings can only span one line. And it complains. Syntax error, I don't have a closing quote. If I want to have a long string that has a lot more content, I can use triple quotes. And it does, in fact, have that embedded new line in it. Triple quotes are also used for documentation. Where do you suppose this documentation comes from? It actually comes from Python source. And the Python syntax specifies some places you can put plain strings. They're not assigned to any variables. And they will actually be stored on the object that contains them. So for instance, the first thing in any Python program can be a triple quoted string that briefly describes the script. and that's not a syntax error. And there are actually ways of programmatically retrieving that. You can also use, this is called docstrings. You can also use docstrings when we get to OOP. You can use docstrings in classes and methods when we get to functions. And again, they'll be remembered and can be retrieved. So all the stuff you're reading when you use the help function is actually embedded via docstrings right in your code. And we'll have a future lab where we'll note you can also embed parsable and runnable tests in your docstrings that verify that the implementation of your program is correct. So docstring is a triple-quoted string that's not assigned to anything and that appears in a few key places. And the key places are the first line of any namespace. So the first line of my script, I have a triple-quoted string. That's actually significant. I'm not assigning it to any variable, but it gets assigned to the docstring variable of my script's namespace.
So when you run the program,
When I run the program, it doesn't appear. You don't see it. But
more like a comment.
It's like a comment, but comments are thrown away when the program is compiled.
Right. Okay.
And this is actually saved and can be later retrieved. So when we use help, we're looking at the docstrings that are embedded in the Python source code of the libraries.
Okay. What's the primary use of that one?
So the primary use of docstrings is to document your code in ways that are runtime introspectable. Because it is very common for somebody to be poking around your Python library in the interactive console, and they don't want to have to go someplace else necessarily to read a quick, brief help.
So
They can look at the documentation. It's actually part of your source code and is retrievable at runtime.
Oh, okay.
So it's a really nice feature built in, and there's a library to let you embed simple tests that look like interactive console sessions that you can then run. So you can say this function does this. Here's an example of it running, and the output should be. And it'll run your doc tests and tell you that all of them are working or not. Which, as long as they enhance your documentation, is a really useful tool. It's not a full unit testing suite, but it's a useful tool. What else about strings here? Let's talk about dicing and chopping strings up a little bit. Strings can be indexed into, although they're not mutable. And we already know everything there is to know about indexing into strings, because it's just like lists. My name, we can get a single position, we can get the last character, we can get a slice, just like lists. Same stuff works on strings. So again, if you're comparing strings and you're looking for a prefix or something, you can use the bracket mini language to do that. There's also split and join built-in functions for converting to and from lists based on a delimiter. So my name, x.split, and by the way, my IPython shell ending with a question mark like that is a shortcut for help x.split, but that is a IPython specific built-in. Don't expect it to work if you're not running IPython, not part of the language. So help on x.split, it splits based on a separator. So x was my name and x.split, and I'm passing it a separator value of a space, returns a list with all the values, no separator. And all right, so y is the list, x is the name, and if I wanted to go the other way,
So the splitter, specifies the pattern where you're going to be inserting a comma,
and
or you're doing a split.
when I'm doing,
You just use a space, you just actually break it up.
Yep.
Into,
and it's not actually a pattern, there is a regex version of split, but the basic version of split is looking for a single character.
single character.
Mhm.
Will it throw away that single character?
And it did, yes.
Right.
Mm-hmm. So I ended up with a list that doesn't contain any spaces, but contains each piece that was between the spaces.
So basically, it's converting a single entity of the string to a list, basically.
Yes.
It has a two string variables after you do the split. Is that right?
Yes. It's a list that contains two strings. To go the other direction, this is a common idiom, and it's kind of confusing. So the string type has a function split that splits a string by a separator. The string type also has a function join, but in this case, instead of taking a separator, it takes a list, and it joins by the value of the string itself. So that line 17 there is really this, z equals a string, and let's go ahead back to spaces, z.join y, and if you remember, y was a list before. So to go back to a string, inserting a separator between the positions in a list, you use the separator as a string and call join. And this works as a shortcut because the string literal there is converted to an object right away, and the string literal has methods. So the first string, it's inside double quotes, is my separator, and it does not have to be a single character. Could be anything. And it'll take a list as an argument, and it'll put all the items in the list concatenated together with the separator I specified. And you will even see sometimes this, because you just want all the stuff in a list joined together with nothing between it. So I have an empty string as my separator. So I generally use single quote whenever I can because it's less key presses. I use double quotes sometimes for long strings because I think maybe I'll type a single quote in it, and triple quotes for when I want to span strings. The other thing is if you want your slash ends. What do I have? Oh. Any PHP programmers here? I thought I saw that on somebody's. PHP makes a difference between single quotes and double quotes as to whether or not it uses the escape character. So when I say /n, this is interpreting it as a new line, and you'll notice both single quotes and double quotes do control character interpolation. /n is a new line, /t is a tab. If you're familiar with them, then this will make sense. If you aren't familiar with them, it won't make a lot of sense. If you want to avoid interpolation, you have to specify that you have a raw string by prefixing your string with an R. So if you have a string that has a slash and a significant character, and this will bite you sometimes because that's fine. There is no /d control character. But just by changing the next character, there is a /t, there's a tab. Suddenly you have a different string than you thought you were getting. So if you're concerned about embedding control characters when you're typing string literals, you can prefix your string with an R for raw. And you can also do that for a Unicode entry if you're doing slash and hexadecimal Unicodes. Although Unicode is going to be beyond the scope of this class and totally changes from 2 to 7. It actually works in, from 2 to 7. Sorry, from 2.7 to 3. It totally works in 3. It's a little annoying in 2.7. We already talked about the built-in function length, which works for strings as well as for lists. And one more piece to mention about strings. Operators, we've used the plus operator for concatenation. There's one other operator very frequently used, and listed here under the additional documentation, which is formatting strings. This is from the book Dive into Python by Mark Pilgrim, which is slightly dated at this point, but is a really readable Python tutorial. The percent operator, which is modulus on integers, is the string formatting operator in Python 2. And it looks for percent signs in the string it's applying. So the percent operator between the strings here is a string formatting operator. Inside my doubly quoted string, this %s is a format code that means convert the first value to %s, or to type string. And it supports a whole variety of formatting options. This says I have a formatting code, starts with %, and then .2f specifies a float with 2 decimal places. And it's converting that float to have 2 decimal places. By default, the string operator uses positional indexing. And it uses tuples, which is going to be the next thing we talk about after lunch. So it put the first string it got, or the first thing it got converted to a string and put in this base string. The second thing it got was converted to a string and put in the base string. When we get to dictionaries, you can also do name-based interpolation instead of position-based interpolation. And there's a bunch of formatting for numbers, for dates, anything for strings. Sadly, no. Tuples only. Tuples are very similar to lists. They're immutable is their main difference. And we'll talk about tuples after lunch. It's our next type. So after lunch, we're going to talk about tuples and dicts. Dicts are key value stores, complex key value stores. And we're going to do a bigger lab, and we'll typically do larger labs in the afternoon. OK, anything else we should wrap up before lunch? I think it's about 5 after or something.